Hey guys, Mr. Gucci here, and this is a help video for the 10.2 Mass Stoichiometry homework. I'm going to walk through multiple parts. I'm going to walk through 4 problems here with you, show you how this is going to go. Okay, so let's get going. Now, the first step in any stoichiometry problem is you have to balance the reaction. So before we get started, step 1 is to balance this reaction. So here we go. 1 potassium, 1 chlorine, 3 oxygens, 2 oxygens. So I'm going to put a 3 there, and that'll make this 6. I'll put a 2 here, and that'll give us 6 oxygens. But now I've got 2 potassiums and 2 chlorines, so I got to put a 2 right there. Okay, that's the balanced chemical reaction. 2, 2, and 3. Okay, with that, I can get started. Now, let's get down to business. We have got in 1A 45 grams of potassium chlorate. That's what you're starting with, 45 grams. And they want to know how many grams of potassium chloride. By the way, important to know, potassium chlorate is this one. So I'm just going to write that in there, KClO3. And potassium chloride is the other one, KCl. Don't get that mixed up. Okay, identify your substances. So we know we are starting with 45 grams of potassium chlorate. Now, after we balance the equation, the thing that has to happen next is we have to convert our starting amount to moles. I don't want to use 2. Let's go with part A. Okay, good. All right, part B, we have to convert our starting amount into, you know what, I don't even like that either. I'm going to use little Roman numerals. Here we go. So I, all right, step 1. All right, step 2, I. Step 2 is we have to convert our starting amount into moles. So we've got 45 grams of KClO3, and we need to convert that into moles of KClO3. Okay, so we're converting from grams into moles. We want to get out of grams, so grams goes on the bottom, and moles goes on top. Now, what's the relationship between grams and moles for KClO3? Well, it's the same relationship as always. It's the molar mass. So I'm going to look up the molar mass of KClO3. Okay, I'm going to pull up periodic table, and I'm going to get a calculator. Okay, so KClO3. So K is 39.10. Cl is 35.45. And then I've got 3 oxygens, so 3 times 16. I get a molar mass of 122.55. So the molar mass of this substance is 122.55 grams per mole. Okay, this is from the periodic table. When we're going from grams into moles, we look at the periodic table. Okay, so 45 grams divided by 122.55, 45 divided by 122.55, we get, as our answer, 0.367 moles of KClO3. Okay, so we have converted our grams into moles. Remember, step 1, balance the equation. Step 2, put our gram amounts into mole amounts. All right, next step, step 3. We have moles of KClO3. We have to convert that into moles of our final substance. In this case, potassium chloride. Okay, so here I go. So we have 0.367 moles of KClO3. And we want to convert into, more space here, moles of our final substance. So moles of potassium chloride. Now you might be saying, but Mr. Gucci, don't we want grams of potassium chloride? Yes, eventually. But for now, we need to figure out the moles first. So here we go. We want to get out of moles of KClO3 and into moles of KCl. Where do these numbers come from that make this work? Well, they come from the balanced equation up above. So in this conversion, we have to use the balanced chemical equation. So what goes in front of the KClO3? It's 2. All right, so here we go, 2 KClO3s. And the number that goes in front of the KCl is also 2. So here we go, 2. All right, well, what we see here is that's a ratio of 1 to 1. So however many moles of KClO3 we use, we get the exact same number of moles of KCl. So if it's 0.367 moles of KCl, that's going to be 0.367 moles. Very good. So 0.367 moles of KClO3 will also give us 0.367 moles of KCl. So good. So now we figured out how many moles of KCl we have got. Okay. Now the last step is we have to convert this final amount of moles right here into grams. And so we'll do that. We got to go from moles into grams. So here we go. Step 4. Here we go. We have got 0.367 moles of KCl. And we want to get that into grams of KCl. So we have to get out of moles and into grams. What is the molar mass of KCl? Well, back to the periodic table I go. Here we go. So K is 39.1 plus Cl, which is 35.45. So it's 74.55 grams per mole. All right, 74.55 grams for every mole. So I'm multiplying 0.367 times 74.55. And I get as a final answer 27.4. There we go. My answer is we will produce 27.4 grams of KCl. Final answer. There you have it. Now, once again, how did we get here? Well, first step, we balanced this equation. We balanced the chemical equation. Second step, we took our starting grams of potassium chlorate and converted them into moles of potassium chlorate. Then third step, we took moles of potassium chlorate and converted them into moles of potassium chloride. Lastly, we took our moles of potassium chloride and converted them into grams of potassium chloride, and that got us our answer right here. So there we go. It's the same steps in all of these problems. The same step in all of these problems. You balance the equation, convert starting amount into moles, go from starting moles into moles of final substance, and then take moles of final substance and convert them into, in this case, grams. Let's take a look at part B. Now, while A, I did exactly the same as your homework, B, right here, I changed the numbers up a little bit. Did I? No, I didn't actually. I just went with the same one. Let's do this. All right, so here we go. Part B. All right, so the first step is to balance the chemical equation, which we already did. Check. All right, now on to the second step, which is to turn our starting amount into moles. All right, so turn our starting amount into moles. Our starting amount here is Our starting amount is 15.4 grams of KCl. So that's what we're starting with. All right. And we need to convert it into moles of KCl. So we're getting out of grams into moles. We are dividing by the molar mass of KCl. We looked that up before. What was that? What was that? Molar mass of KCl was 74.55 grams per mole. Here we go. All right, so it's 15.4 divided by 74.55. And that gets us 0.207 moles of KCl. Okay, very good. Now that we've got moles of KCl, the next step is to take moles of KCl and convert them into moles of whatever final substance we're trying to work with here, which in this case is O2. So we're going out of moles of KCl into moles of H2. Here we go. So we have got 0.207 moles of KCl, and we're trying to figure out what that is in moles of O2. So we'll do a little conversion here. We're getting out of moles of K, let me make this cleaner. Moles of KCl into moles of O2. All right. Now, when we're going mole to mole conversion, where do these numbers come from? They come from, of course, the balanced chemical equation up above. So in this case, we're going from KCl into O2. We see KCl is 2 and O2 is 3. So for every 2 KCl's produced, we also produce 3 oxygens. So 2 KCl's and 3 O2s. So to solve this, it's just going to be 0.207 times 3 over 2. And we get, let's see here, 0.311 moles of O2. Okay, now we're in moles of O2, and it's time for the fourth and final step. The fourth and final step here is once we figure out how many moles of product we have got to convert that into what unit they want. In this case, they want grams of O2. So let's go from 0.311 moles of O2, and we need to get into grams of O2. So we're getting out of moles of O2 into grams of O2. All right, what is the molar mass of O2? All right, well, again, I'll go to the periodic table. When we're doing mass conversions, we use the periodic table. Oxygen is 16, and so O2 is 16 times 2. 16 times 2 is 32. All right, so every 1 mole of oxygen is 32.00 grams. What about Mr. Gucci? Wasn't it 22.4 before? It's 22.4 if we're doing a liter conversion, but we're doing a gram conversion, so no. All right, so 0.311 moles of O2 times 32 grams per mole, and we get, as our final answer, 9.95 grams of O2. The answer is we will produce 9.95 grams of O2 in this reaction. If we produce 15.4, let's read this question. If we produce 15.4 grams of KCl, we will also produce 9.95 grams of O2. There we go. Now this was, I think, a fairly long video. So I'm going to stop here and I'm going to make a second video in which I do questions 2A and 2B. That should be 2B right there. Nope, nope, nope. You're going to be B. You can be, start, nope. I'll deal with this later, guys. Anyways, have a good day, and all right, check out the second video, which will be uploaded shortly. Bye.